So welcome to the another video on equivalent resistance. So here you can see this circuit. So for this one AB across AB only we need to find. So if I draw the dotted line, that becomes a folder symmetry. So you can see both the R and R are in parallel, and since these two bottom of horizontal two R value get cancelled out. Okay, so if it is crosses the folder line, these two get cancelled out. So I'm going to redraw the circuit. Okay, and I'm going to fold this resistance. So if I remove this resistance, the circuit will look like this. So I'm going to fold the right hand side to the left hand side. Okay, so if I fold this R becomes R by 2, since these two resistors are in parallel. So this is R by 2, and here you have R. Okay, this is B and this is A, and you can see this R and R are in parallel, so it becomes R by 2. And similar way, this two are in parallel, so this is R by 2. Okay, so now you can see this R by 2 and R by 2 are in series, right? So this is R by 2, this is R by 2, right? And this is B, so this is R, this becomes R, right? Because R by 2 plus R by 2 is R. So now you can see R by 2 and R are in series. So what is R by 2 plus R? That is what is the value? 3R by 2. Okay, so now this 3R by 2 and R are in parallel, so I can write 3R by 2 into R, right? 3R by 2 into R divided by 3R by 2 plus R. So here R and R get cancelled out, so you will get 3R square divided by 2 into 5R by 2, right? So you will get 2 and 2 get cancelled out, so you will get 3R by 5. So next problem. So it is similar to the previous problem, but you can see A and B are different. So for that one you have to find the so I'm going to draw the mirror symmetry. So across this line you can see all the resistance right and left hand are equal. So since along the mirror symmetry line you have a resistance, so you have to remove that one. Now you can see R and R are in series. This 2 are in series, so it becomes 2R, right? So I am going to redraw the circuit. So this is R and this is R, right? So this is also R. Okay, so from here this is A and B, so I'm going to draw this is 2R, right? This resistance is 2R, and from A to B you have another resistance that value is also 2R. So now you can see 2R and R are in parallel, so I can write R equivalent is equal to 2R into R divided by 3R, right? So here R and R get cancelled, so R equivalent is 2R by 3. So now I am going to replace this diagram. Okay, so this is how the circuit will look like, right? And here you have 2R, right? So now you can see R, 2R and R are in series. So you will get 2R plus this is R and this 2R plus 2R by 3. What is 2R plus 2R by 3? That is 6R plus 2R by 3, that is 8R by 3, right? So this is 2R and this one is 8R by 3, right? 2R plus 2R by 3 is 8R by 3. So now you can see across A and B, you have 3 resistance which are in parallel. So now what is the formula? 1 divided by R equivalent is equal to 1 divided by R plus 1 divided by 2R plus 1 divided by 8R by 3. Okay. So here I can multiply it as 8 plus 4 plus 3 divided by 8R. That is equal to 15 by 8R. So what is my R equivalent? R equivalent is equal to 8R by 15. So let us go for the next problem. So this all the resistance is so this is a 10th problem. So here I can go for mirror symmetry. You can go for both one. No, I can only go for the mirror symmetry. So you can, if I apply mirror symmetry, the right hand side and the left hand side values are same. Okay, and you can see at the center point both the 4R are meeting, right? So I can write this one as 2R, right, and this one as 2R, and this is 2R, and here also you have 2R, right, and this is A and B. So it has to cross this pink line. So you have to draw like this only. So okay. So this is an important point. Okay. So since it crosses the pink line, you have to draw like this. Okay. So now you can see this 2R and 2R is parallel. So it is R, and this is 2R, and this is 2R, and 2R and 2R are in parallel, so I can write it as R. Okay, this is AP. So I can redraw it as this is 2R plus R plus 2R is 5R, then this is R. Okay, so what is R equivalent? R equivalent is equal to 5R square divided by 6R. So that is 5R divided by 6. That is the answer. So I can take this circuit and I'm going to copy it and I'm going to replace A and B. Suppose the A and B are in this point. Okay, so this is your 11th problem. Okay. So this is an example for the folded symmetry. Okay. So suppose if A and B are here. Okay. So let me erase this one. So now I can apply folded symmetry, right? So if I apply folded symmetry, okay, it should not cross a point. So if it should not cross a point, you have to draw the resistance like this. I will explain you. So this becomes R by 2 because R and top and bottom, okay, that can combine. So here also you have R by 2, okay, this is also R by 2. So you can see the top point, okay, this is R by 2, okay, now this is also R by 2. So I can draw this is R by 2 and this is also R by 2, right? So it is not touching the point. Okay. So now R by 2 and are in series. So I can write it as R and R. Also R and R are in parallel. So you can write it as R by 2. So you can see R by 2 plus r by 2 plus r by 2 is 3r by 2. Right, so this answer. Why